6 planets are visible in the night sky simultaneously right now. Not 6 points of light that require a telescope to see. 6 worlds visible with the naked eye, strung across the pre-dawn eastern sky in a diagonal arc from the horizon upward, in an arrangement that professional astronomers are describing as one of the most visually striking planetary alignments in more than 2 decades. Venus, Mars, Jupiter, Saturn, Uranus, and Neptune are aligning in the eastern sky this week, with 4 of the 6 visible to the naked eye and 2 requiring only basic binoculars to identify clearly. If you have not looked up yet, you are missing one of the rare moments when the solar system itself arranges into a configuration that makes the architecture of the cosmos feel immediately and personally visible from your own backyard. This is not a coincidence of perspective. This is not an optical illusion. This is 6 planets occupying specific orbital positions around the Sun simultaneously, such that, from Earth's vantage point, they appear distributed along a band of sky called the ecliptic, the apparent path of the Sun across the celestial sphere, in a configuration that the mathematics of planetary orbital periods only produces at specific and relatively rare intervals. The last time this many planets were visible in approximate alignment simultaneously was in 2022, and the configuration currently unfolding is described by observational astronomers as more visually striking than that event due to the specific spread and brightness of the planets involved. It is August 2nd, 2026. The world is consumed with conflict, with economic uncertainty, with a relentless pace of news events that can make it feel as though the universe itself is contracted down to the dimensions of whatever crisis is dominating this week's headlines. Tonight, and for the next several nights, the universe is literally visible in the pre-dawn sky at a scale and in a configuration that invites something that the news cycle rarely allows: a moment of genuine perspective. Let's build a complete picture of what is happening in the sky above you, what it means scientifically, why it looks the way it does, and what you need to do to see it at its best. Start with what you're actually looking at, because the phrase planetary alignment can mean several different things in astronomy and popular science, and being precise about what this specific event involves matters for understanding both what you are seeing and why it is. Genuinely rare. A true planetary conjunction, in the strictest astronomical sense, occurs when 2 or more planets appear to occupy the same point in the sky, or very close to the same point from Earth's perspective. The planets are not actually near each other in space. They are at vastly different distances from Earth, separated by hundreds of millions to billions of kilometers. The proximity is purely geometric, a matter of how their orbital positions project against the distant background of stars when viewed from Earth's specific location. What is happening right now is a broader and more visually spectacular version of this concept. The 6 planets are not all occupying the same point in the sky. They are spread across a significant arc of the sky, distributed along the ecliptic in a diagonal line that extends from low on the eastern horizon upward into the pre-dawn sky. The alignment is not a perfect straight line. It is a graceful arc following the ecliptic's curve, which is itself a consequence of the geometry of the solar system. All the planets orbit the Sun in roughly the same plane, so when multiple planets are visible simultaneously from Earth, they always appear distributed along the same band of sky. The current event is striking because so many planets are currently positioned on the same side of their respective orbits, creating the appearance of a gathering that spans the inner and outer solar system simultaneously. The order in which the planets appear along this arc, from the horizon upward in the pre-dawn sky, reflects their orbital positions and their distances from Earth at this specific moment. Venus is the brightest and most easily identifiable, blazing as the brilliant morning star low in the eastern sky before sunrise. Venus is currently at a point in its orbit where it is relatively close to Earth and presenting a phase comparable to a half-moon if viewed through a telescope, which is why it appears so intensely bright. At approximately -4 magnitude, Venus is roughly 6 times brighter than Jupiter, which appears next in the arc at approximately -2 magnitude, still bright enough to be unmistakably visible to any observer who steps outside before dawn. Mars appears further along the arc, currently at a moderate brightness due to its orbital position, reddish in color in a way that distinguishes it clearly from Venus and Jupiter even without optical aid. The distinctive rust-red color of Mars is not simply an astronomical curiosity. It is the visible consequence of iron oxide, effectively rust, that coats much of the Martian surface, absorbing blue light and reflecting red wavelengths back toward Earth in ways that give the planet its characteristic appearance even across the hundreds of millions of kilometers, separating it from observers on Earth's surface. Saturn appears further along the arc, golden-colored and steady, without the twinkling that stars exhibit due to atmospheric turbulence. Planets, because of their apparent disk rather than the point source nature of stars, are less susceptible to the atmospheric scintillation that causes stars to twinkle. This difference, planets shine steadily while stars twinkle, is one of the simplest and most reliable ways to distinguish planets from stars in the night sky without any equipment whatsoever. Uranus and Neptune require binoculars or a small telescope to see clearly, though both are technically at the edge of naked eye visibility under very dark sky conditions far from city light pollution. Uranus appears as a small blue-green disk even in modest binoculars, its color the result of methane in its atmosphere absorbing red wavelengths. Neptune, significantly further from Earth, appears as a tiny blue dot even in binoculars. Requiring a telescope to show any disk at all, their presence in the alignment, even if they are not the visually dominant elements of the scene, is part of what makes this a genuine six-planet event rather than simply a gathering of the naked eye planets. Now, let's talk about the specific viewing window, because knowing when to look and how to prepare makes the difference between catching this event at its best and missing it entirely, or seeing it only partially. The optimal viewing window is the period from approximately 90 minutes before sunrise to approximately 45 minutes before sunrise. During this window, the sky is dark enough for the planets to be clearly visible with no competition from twilight's growing brightness, but Jupiter and Venus are high enough above the horizon to be seen clearly without the atmospheric haze and distortion that affects objects near the horizon. The planets that are higher in the arc, including Saturn and Mars, are well positioned throughout a longer window because they do not spend as much of the viewing period near the horizon. The event peaks in visual impact over the next several days. While planetary alignments of this type unfold over periods of weeks, the specific configuration, where all 6 planets are simultaneously above the horizon before dawn and simultaneously visible in the best conditions, window represents a shorter peak period. The alignment has been building over several weeks, as the planet's orbital motions have been gradually bringing them into their current apparent positions, and it will gradually dissolve over the coming weeks, as those same orbital motions carry the planets into different configurations. Location matters significantly for the viewing experience. Urban areas with substantial light pollution will reduce the visibility of the dimmer planets, particularly Uranus and Neptune, and will increase the difficulty of seeing the full arc clearly. Suburban locations can provide adequate views of the 4 brightest planets without specialized equipment. Rural locations far from artificial light sources provide the optimal conditions for seeing the fainter planets and for experiencing the full visual impact of the alignment against a properly dark sky. Equipment is not strictly required for the brightest 4 planets, but binoculars substantially enhance the experience and open up the 2 fainter planets that might otherwise be missed. A pair of 7x50 or 10x50 binoculars, the kind used for bird watching or sporting events, is entirely adequate for this kind of observation. They will show Venus as a distinct crescent shape rather than simply a point of light. They will show Jupiter's disk, and under steady atmospheric conditions, hints of its banded cloud structure. They will show Uranus and Neptune as distinctly non-stellar objects, rather than requiring you to trust that a faint point of light at a specific location in the sky is actually a planet. A small telescope, even an inexpensive beginner's instrument of 60 to 80 millimeters aperture, transforms this observation into something extraordinary. Saturn's rings, tilted favorably toward Earth at present, are visible even in small telescopes, and seeing Saturn's ring system floating in the eyepiece while knowing you're looking at a world larger than Earth is one of the most emotionally affecting experiences that astronomy routinely provides to people encountering it for the first time. Jupiter shows multiple cloud bands and its 4 Galilean moons, the worlds that Galileo Galilei observed in the early 17th century and whose existence proved that not everything in the solar system orbited Earth. The visual connection between what you see through even a modest telescope and what Galileo saw with his primitive instrument 4 centuries ago makes the observation a genuinely historical experience, as well as an astronomical one. Now, let's talk about why this specific alignment is scientifically interesting beyond its visual spectacle, because the planetary positions that produce a gathering of this kind encode specific information about where we are in the cyclical dance of solar system orbital mechanics that has been running for 4.5 billion years. The planets of the solar system orbit the sun at different distances and at different speeds, a consequence of the same gravitational physics that Isaac Newton systematized in the late 17th century. Mercury, closest to the Sun, completes an orbit in about 88 days. Venus takes 225 days. Earth takes 365 days. Mars takes approximately 687 days. Jupiter, far larger and much further from the Sun, takes almost 12 years to complete a single orbit. Saturn takes approximately 29 years. Uranus takes 84 years. Neptune, the outermost planet, takes approximately 165 years to complete a single orbit of the Sun. Because each planet orbits at a different speed, the geometric relationships between the planets change continuously. 2 specific planets align in the same region of the sky at intervals that depend on the ratio of their orbital periods, a calculation that produces what astronomers call the synodic period of a planet pair. When you extend this calculation from 2 planets to 6, the result is a configuration that occurs significantly less frequently than any individual 2-planet conjunction. The specific combination of 6 planets, distributed along a significant arc of the ecliptic in the configuration currently visible, represents an orbital geometry that the mathematical cadences of planetary motion produce only rarely. Historical records of planetary alignments go back to ancient civilizations that tracked planetary positions with remarkable accuracy using naked eye observation. Babylonian astronomical tablets from more than 2,000 years ago document planetary positions with sufficient precision to allow modern astronomers to trace the history of planetary configurations backward through time and identify when previous occurrences of configurations similar to the current one occurred. The Babylonian astronomers who developed the mathematical framework for predicting planetary positions were doing what amounts to the same mathematical modeling that modern orbital mechanics software performs, just with different tools, a different theoretical framework, and on clay tablets rather than computer screens. The ancient civilizations that tracked planets with such dedication did so partly for agricultural and navigational purposes, partly for astrological significance, and partly from what appears to be genuine intellectual curiosity about the patterns governing the sky. The specific question of why the planets moved the way they did, rather than simply what pattern they followed, was the intellectual engine that eventually produced the heliocentric model, the telescope, the laws of motion and gravitation, and ultimately the entire edifice of modern astronomy and physics. When you look at the pre-dawn sky this morning and see 6 planets arranged along the ecliptic's arc, you are looking at the same objects that every human civilization has observed since before written history, the planets that ancient Babylonian astronomers tracked on clay tablets. The planets that Galileo turned his telescope toward in 1609 and discovered moved in ways that the Earth-centered model of the universe could not explain. The planets that Newton's laws of gravitation unified into a single mathematical framework that could predict their positions centuries into the future. The continuity of that observation from Babylonian astronomers watching Venus rise before dawn on Mesopotamian plains to modern observers with smartphones and binoculars in suburban backyards is one of the more profound aspects of the planetary alignment's significance. The sky is the one thing that every human civilization across every continent in every historical period has shared. The specific planets visible in the current alignment were visible to every ancient culture that developed astronomical traditions. Now let's examine the specific aspect of this event that has been generating the most public interest beyond the immediate visual spectacle, which is the question of when the next event of comparable scale will occur and what makes this one specifically notable compared to similar events in recent memory. The 2022 planetary alignment that received significant public attention involved 5 planets, not 6, and occurred in a slightly different configuration. The current 6-planet event is broader in the number of planets involved, and is occurring in a configuration that places the planets distributed across a larger arc of the sky, making the full extent of the alignment more immediately visually apparent than an event where the planets are clustered in a smaller sky region. Looking forward from the current event, the next comparable alignment involving 6 planets in similarly favorable pre-dawn visibility is not expected until 2040, more than 14 years from now. This forward-looking rarity is part of what makes the current event worth prioritizing. Astronomical events are easy to postpone because they feel permanent and recurring, an attitude that leads many people to miss remarkable events with the intention of catching the next one. The next one is in 2040. The current one is happening right now. There is also a specific historical resonance to the current alignment that goes beyond its visual and mathematical characteristics. The planets that are gathering in the pre-dawn sky are the same objects around which this civilization has been building its understanding of physics, mathematics, and the nature of the universe for millennia. A 6-planet alignment is one of those rare astronomical events that bridges the ordinary and the extraordinary, visible to anyone who steps outside at the right time and looks in the right direction, but simultaneously connected to the deepest questions about the solar system's history and humanity's place within it. Now, let's talk about what this alignment means for specific aspects of astronomical science that have practical relevance beyond simple observation. Because one of the things that makes planetary alignments scientifically valuable is the specific observational opportunities they create for studies that benefit from multiple planets being simultaneously accessible. Comparative planetary science benefits from alignment periods because astronomers conducting long-term studies of multiple planets can reduce certain systematic observational biases by making observations of different planets under similar atmospheric and instrumental conditions in the same observational sessions. The current alignment provides astronomers studying comparative atmospheric dynamics across the outer solar system, with an unusual opportunity to observe Jupiter, Saturn, Uranus, and Neptune within the same short observational window on the same nights. allowing direct comparison of observational parameters that would otherwise be separated by different seasonal accessibility across multiple observing campaigns. Gravitational wave detection research, while primarily focused on sources far more energetic than anything in the solar system, benefits from precise knowledge of planetary positions because planetary gravitational perturbations are among the factors that space-based observatories must model accurately to achieve the measurement precision that gravitational wave detection requires. Alignment periods, when multiple planets have their positions precisely measured by numerous independent observing programs, contribute to the orbital parameter databases that this precision modeling depends on. Spacecraft navigation for ongoing deep space missions also benefits from precise planetary position measurements during alignment periods. Several active spacecraft are currently en route to or operating at outer solar system destinations, and their navigation teams use ground-based planetary observations to calibrate the radio navigation solutions that determine spacecraft position and trajectory. An alignment period in which multiple planets are simultaneously well positioned for observation provides useful calibration data for this navigation work. Now, let's look at the practical guidance for tonight's observation, because the most scientifically interesting and historically resonant alignment is only valuable if people actually go outside and look. The single most important preparation is setting an alarm for approximately 90 minutes before your local sunrise. This is the time when the viewing window opens and conditions are optimal. Most people who intend to observe an astronomical event but do not specifically prepare for the wake-up time miss it, because 90 minutes before sunrise is early enough to require deliberate planning. The second preparation is identifying your eastern horizon. The alignment is in the pre-dawn east. You need a view of the eastern sky with minimal obstructions, which in practice means being outside your house rather than watching through a window and choosing a viewing spot where trees, buildings, or other obstructions do not block the low eastern horizon where Venus will be most prominently placed. The third preparation is allowing your eyes to dark adapt before beginning the observation. The human eye requires approximately 20 minutes of darkness before reaching its maximum sensitivity to faint light. Going directly from a bright indoor environment to trying to see faint planets results in a significantly compromised observation compared to spending a few minutes in the dark before beginning to look. The fourth preparation is dressing for the conditions. August. Pre-dawn temperatures vary significantly by location and altitude, and the hour or more you might spend outside for a quality observation is long enough for temperature discomfort to significantly reduce the experience. Comfort promotes patience, and patience is what separates a quick, partially processed observation from the kind of sustained viewing session that lets the full scope and beauty of what you're looking at register emotionally and cognitively, rather than just being seen and forgotten. The alignment is happening right now. The planets do not care about the news cycle, about conflicts, about economic conditions, or about any of the human dramas that occupy the foreground of daily attention. They are where the orbital mathematics of the solar system placed them, where they have been slowly moving for 4.5 billion years, and where they will continue moving for 4.5 billion more. The specific configuration that places 6 of them visible simultaneously in the pre-dawn sky right now will not recur in this form until 2040. 90 minutes before sunrise. Eastern sky, 6 planets. The solar system is showing you its architecture directly, without mediation, requiring nothing more sophisticated than your own eyes and the willingness to be outside in the dark for a few minutes before dawn. The universe arranged this. You simply have to look up.